So join it there if you want. Okay, so I'm going to start. So I'll bring up the annotations. So we're starting on threads. Okay. So what are threads? Okay, so to start again. So we've only been dealing with so far when we do programming. Let's say step 1 happens, then step 2, then step 3, then step 4. Okay, so it's a single thread. So you have a single line of control going through your program. All right. Now, with threads, you can have multiple lines of control going through your program at the one time. All right. So things no longer just go on one single line of control. You can have multiple lines of control going through your program at the same time. All right. Now, also, threads are something called asynchronous. Now, what asynchronous means is we're used of one task completes, then another task. So the next task doesn't start till the previous task completes. Yes, you understand that? Now, threads don't operate that way. So if one task finishes, the next task starts. That's synchronous. Asynchronous is you could be halfway through the first task and the next task could start. And even you could have 4 tasks queued up and the second task could start before the first task. All right? Or they could be starting at the same time. That's asynchronous. Threads are at their very nature asynchronous. Okay? So you have 4 different threads. They could all be running at the same time. You could have thread A starting before thread B, or thread A could start in the middle of thread B, or you could have A, B, C, and D threads all starting at the same time. You could have A starting in the middle of B. You could have D starting first, then A, then B, then C. Okay? So, now, they do offer great usage in that it speeds up your application considerably. All right? The main problem with it was this, is that you can never be too sure when a certain thing is going to happen. Okay? You can't be threads by the very nature means you don't know if B is going to follow A, you don't know if C is going to follow B, you don't know if D is going to follow C. You can with just a single threaded application, you've just one line of control. With threads, anything can happen. Any order can happen. All right. So the main thing with threads is managing them. All right. Now so the previous version of managing threads is in Java 7, which is not on this exam, but I will probably have to show you because if you go out with the workforce, probably the old way of doing threads is going to be still the same way they're going to be used. All right. This way is a hell of a lot easier. All right. Now, a thread can have many tasks in it. Okay. So each of these threads, these are 4 lines of control going through your program. And what you do is you put tasks on a thread. That's the best way to describe it. All right. So a thread can have many tasks on it. You could have one task would be to define variables. The next task could be to get input from a user. The next one could be to create objects from the data you have from your user. All right. So this could be the thread to look after your GUI, everything to do with your GUI. This could be the thread. Oops. This could be the thread to look after user input. This could be the thread that looks after your database. This could be the thread that looks after your files, right? So you have 4 separate areas. They're all working at the same time. And each one of these threads has tasks on them. So you can load up tasks onto your threads, all right? Now, we primarily use, in Java, we're going to be using single threads, okay? Now, as far as I know, multi-threads are not on the exam, all right? So, but you can still do basically the same things with single threads and multi-threads. There isn't a whole pile of difference, all right? Now, so you can have many threads in your program, and each thread can have many tasks in it, all right? Now, threads, so I'll take rid of all this shit again. Okay, now, so we have our 4 threads going through our program. So as I said, this is for GUIs, this is for, so this is GUIs, this is user input, this is database, and this is files. Okay, now, you load up your tasks in here. Now, your tasks in your thread can be synchronous or asynchronous. Now, what that means is, so the threads are by their very nature asynchronous. So the 4 of them can be run at the same time. And each thread can have many tasks on it. Now, the tasks can be either asynchronous or synchronous. Now, synchronous means, synchronous is the easy one. So in the GUI, you would have to create your logon screen, create all your other screens, right? So that's the 2 basic tasks you have in it. Create your logon screen, create all your other screens, okay? Now, so what you can have, you can create your logon screen first, then create all your other screens. Or you can assign them to be asynchronous, which means it could create all the other screens before the GUI. Okay? Is everyone with me so far? Yes? So threads are by their very nature asynchronous, but the task within a thread can be either synchronous or asynchronous. All right? Now, with all of this, the main thing is all about managing threads. All right? Now, there's a new way in Java 8, and it's called executor service. All right? It's called executor service. What is executor service? Executor service. That's for managing your threads and managing your tasks on your threads. All right? Now, that's what threads actually are. All right? So with that, I'm going to create a few threads. So EX1. So any class that wishes to use threads has to implement the runnable interface. Okay? So any class that wishes to use threads has to use the implement the runnable interface. So it's a functional interface, which means it can be used with lambdas. Okay? And it's functional interface, public interface, runnable. It has one method. The method it has is returns nothing, takes nothing, and it's called run. Okay? So here's a couple examples of runnable. That's a runnable lambda, that's a runnable lambda, that's a runnable lambda. Okay? So then I'm going to R1.run, R2.run, R3.run. Okay? So nothing too complicated there. Now, that's not the thread itself. Okay? That's not the thread itself. That is merely what goes in the parameter when you're creating a thread. What I show by that, I'll bring this guy down here. And I put a thread in here. Okay, now, so I'll explain it this. So creating a thread is a two-step process. Okay. First, you define the thread. That's the first part. Okay. So here we define the thread. Thread T1 is equal to new thread. Now, what goes in here is the task you want to be completed by the thread. Okay. So what goes in here? That's the task you want the thread to complete. So we've got thread T1 is equal to new thread, new print data. So I have a class called print data. Now that is basically the task you want the thread to complete. Okay, that is the task you want the thread to complete. Now what is that task? If I look in print data, I see that you have a method called run. And all that happens is before loop, it has a for loop that executes 10 times. Okay, so the task that this thread is going to complete, that's the task. So the task is what's contained within the run method. Okay. Now, so this guy here is our first task. Thread T1 is equal to new thread, new print data. Now, to cause this task to execute this thread, you go T1.start. So the name of the thread is T1. To execute this thread, you have to go start. Okay? That will cause our thread to execute. Now, so I create a thread. That's the task I want to accomplish. Okay? Now you can have multiple tasks in a thread. I'm not going to do that quite yet. This is a single thread with just one task. Okay? This is a single thread with just one task. What's the task? It's going to print off 10 numbers. All right, that's all it does. Okay? This one here, new thread, that creates a new thread. This is the task we want to complete within the thread. This causes the thread to execute. Okay, so that's the new thread. That's the task we want to be accomplished within the thread. That executes the thread. So new thread, new print data, start. Now, so the way we have it done is, so I'll just get rid of everything here again. So T1.start, we have a static int counter. Okay, static int counter is equal to 0. Now, for this one here, that's going to go from 0 to 9. Okay. Then we call another print data one, that's going to go from 10 to 19. Yes? Okay. Now, here's the thing. You can guarantee that the T1 thread is going to go from 0 to 9. You can guarantee that, so this is the T1 thread. Okay, this is the second thread, which is that guy. I haven't assigned it a variable, so that's just our second thread. And we can be sure that the second thread goes from 10 to 19. Now here's the thing, we can't guarantee that T1 is going to do all of its stuff before T2 starts, or before this one starts. I'll show you what I mean by that. Okay, so I am going to go to main. Right, and so ex2. So let's see. Okay. Try and run it again, see if try it once more. Yeah, I'll explain what I'm trying to do here in a minute. Right. So we get naught. Now, just ignore that the numbers are small between out of sync for the moment. Okay. But we can see that it goes from naught to 9. Yes? Yeah? Now, it's not happening here, unfortunately, because it's too fucking efficient. But what you can get sometimes is, so this first counter goes from 0 to 9, or it goes from 0 to, let's say, 7. And then the second counter starts here, 10. And then all of a sudden you have a 7 appeared in the middle of the second count. Okay? What that means is that the second thread has started before the first thread has got to the end of its count. Okay?
That's known as synchronous.
That's asynchronous. Okay? So I am, Iggy. I am. Okay? Now, because I was messing around with it there and I made it too efficient. It was working Friday the way I wanted to work, but I kept doing something because it was some other code I was doing. So what you can end up with was this. So you could end up with 0, 1, 2, 3, 4, 5. And then the second thread starts. Okay? Now the second thread, here's where it starts getting kind of complicated. It doesn't know whether to start at, does the second thread start at 6? Right? Because it's a static counter. The second thread could start at 6. Okay? So we could go 6, 7, 8. That's the second thread. Then it goes back to the first thread, which is going to be 9. Hold on, I said that wrong. Say that again. Okay. 0, 1, 2, 3, 4, 5. Okay. Now you have your code done out in such a way that it knows it's going to start at 10. Second counter starts at 10. So it's going to start the second thread at 10, 11. And then it goes back to, the first thread. I'll make this smaller again, so I'll start that again. It's going 0, 1, 2, 3, 4, 5. Then it goes on to the second thread, 9, 10, 11. Then it goes back to the second thread, 6, 7, 8. And then it goes back to 12, 13, 14, 15, 16, 17, 18, 19. Okay, so what can happen is that the second thread starts executing in the middle of the first thread. If there's something called a thread scheduler that's working in the background there. If your thread scheduler is particularly bad, you can actually start the second thread before the first thread. So you end up with 9, 8, or 9, 10, 11, and you can get 1, 2, 3. All right, so the order inside each one of the threads for this one is going to be one after the other. Okay, but you can't guarantee the order the threads are called themselves. I'll try and explain that again. We have a T1 thread. We have a T2 thread. We have a T3 thread. T1 goes from 0 to 9. T2 goes from 100 to 110. T3 goes from 200 to 210. Okay. Now, so you can imagine each number is a new task. So this goes from 0 to 9. This goes from 100 to 110. This goes from 200 to 210. All right. However, you could end up with something like this. You could end up with 0, 100, 200. Then we go 1, 2. Then it goes 201, 202. Then it goes 101, 102. So these are in the order. So these T1 will always go from 0 to 9, but they could be stuck in the middle of T2. They could be stuck in the middle of T3. T3 could be stuck in the middle of. So you can see here that this is T1. This is T2. This is T3. This is T1. This is T1. T1 is still going only from 1 to 9. T2 is still only going from 201 to 202, or from 101 to 110. T3 is always going from 200 to 210, but they can be all intermingled. All right? It doesn't go 0 to 9, then 100 to 110, then 200 to 210. It can be all mushed in together. So the order is maintained within the thread, but the order of the threads being called can be all over the place. Does that make sense? So the order inside the threads themselves is maintained. Now, these are with synchronous threads, single thread applications, right? So you T1, T2, T3. T1 will always go 0 to 9. T2 will always go 100 to 110. T3 will always go 200 to 210. It's asynchronous, but inside the actual thread itself, it goes from, yeah, it goes one after another. So inside the tasks inside the thread, what we're dealing with, they're going to be synchronous, but the threads themselves are asynchronous. Okay. So the threads are asynchronous, but what's happening inside the threads for now is synchronous, one after the other. Okay. Now this is only numbers 0 to 9. It can also be carrying out 10 different tasks inside the thread. Okay, so these are just printing out numbers. It can also be doing 10 different tasks. All right, for now they're going to be synchronous. So the T1 thread could be, for instance, I'll change this again. So T1 is to do with database. T2 is to do with files. So first item of the thread will be connect to database. Second item of the thread will be to get information. Third task would be to close connection. Okay, so those tasks inside that thread come one after the other. T2 could be a create file, write to file, access file, close file. Okay, those tasks come one after another. Now the thing is, there are two different threads. I'm sorry. There are two different threads, so that it could be connecting to the database at the same time as it's writing to a file. Okay? Now, there are two separate threads. They're not interacting with each other, so you don't have a problem there. Yes? Now, you could have problems if you were creating the file from what's in the database. Do you understand what I'm saying? Because it could have connected, it could have got information, and while it was waiting for the information, it could have closed the file. You mightn't have saved it as a variable. All right? So the order inside the threads is still going to be synchronous, but the threads themselves are asynchronous. So it could be connecting to the database as it's closing the file here in T2. Yes? You understand that? Okay. Right. So that's how threads work. So we're building up to using these things called executor service. So executor service takes all the management away from you. It basically lets Java manage your threads for you. Okay? It makes threads considerably easier to use. So clear all drawings. So here, we started off by creating a thread. New print data. So new thread, this is the task. The task is not going to execute until you go start. Here, I create a new thread with a new task. What's a task? A task is something that implements the runnable interface. Okay? To execute your thread, you have to go start. Here, I have a runnable object, a runnable lambda. So it's a run method. It returns void. It takes no parameters. Okay, so thread T2 is equal to new thread R1. And then I go here, T2.start. To main. Now, all that happens is that it prints off R1 runnable lambda. Okay, and as well here, if we look here, so I go, that is our thread. Then it prints off first thread, which is there. Now, T1.start, the thread doesn't actually start running till somewhere down here. Because look at it, prints off first thread. Then it prints off second thread. Okay? So here you can see you can't guarantee order. You would think that T1.start would print off. Now, what would that print off? New print data. If you look at new print data, that prints off a loop. Okay? However, we can see here that that prints first. Now, it doesn't print the loop here yet. It prints off that first. And inside print data, we have the words before loop. All right, so it goes first thread, second thread. Then before the loop is printed off, now it's there twice. Why is it there twice? Because for that one and for that one. Okay. Now, so that's for first thread. Probably, but we can't guarantee it. That's for the second thread. Probably, but again, we can't guarantee it. And it's going to run, you can see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the way down. 4. And we're going here to 6. You can see how you get strange results sometimes. You have a 6 coming up there. Now, it'd take me a while to figure out why the 6 is coming up there, but that's the sort of things you can get. It's still producing the right answers, but the order can seem a bit strange. Okay? Now, so you create a thread. Now you create a thread is, it takes something that implements the runnable interface. That's a task, right? So a thread can carry out tasks. What's a task? A task is something that implements the runnable interface. It's something you want to do. Okay, so that's one way of creating a thread. This is also creating a thread with the task and then pressing start after it. This is a thread with a runnable lambda, which is also a task. So this guy here, that's task. Okay, it can call any method you want, do whatever you want. So that's a lambda implementation of the runnable interface over here. So this is a lambda implementation of the runnable interface. So this is a task you want a thread to complete. Okay, so something that implements the runnable interface is a task. Okay, how do you start? How do you execute the thread? This executes the thread. Now, so there's another way of creating a thread. Now, this is an unusual way of creating them. This was more of the old way of creating threads. All right. If I go to a class called myThreads, and this extends thread. Okay. I'm going to override. So the thread class implements the runnable interface itself. Okay, so I go at override public void run, and this is using extends thread to create a thread. So this is another way to create a thread, but this is not the usual way in Java 8. All right, so you quite simply go back to here. So I go new my threads this way. Okay, so that creates thread. Okay, that creates a thread. We're going to start it, which causes that guy to be run, and that is going to be using extends thread to create a thread. I'm not too sure, Jason, why actually. Okay, and let me just try something here. So go my thread, my t is equal to new my thread, it's my threads, and my t dot start. Yeah, I'm not 100% sure why that has to be in brackets like that, because that should work as well. Yeah, that should work. Yeah, I don't know why I put it in brackets. Huh?
You're saying there doesn't have to
No,
be-
it doesn't have to be. No, no. Okay, so this is a less common way to create a thread. Okay, my threads extends thread. Okay, so in most cases, you should implement the runnable interface rather than extend the thread class. So this is not the way to create threads. Okay, you use something that implements the runnable interface. Now that can be a class that implements the runnable interface or a lambda that implements the runnable interface. Okay, with Java 8, more often than not, it's going to be a lambda that implements the runnable interface. Now, so we want to show you some of the unpredictable natures of threads. All right, so we're going to go to static void ex3. Now, I am going to, before I go to that, make sure you have static int counter is equal to 0. Okay?
John Shadlow, please call reception. John Shadlow, please call reception. Thank you.
So I'm going to check something here on this other one I have here to make sure this is done right. Right. Now, so we are going to create, so this is this is threads without sleep. Now, again, this is more kind of Java way of dealing with sevens. There was something called thread.sleep. Okay. We have to show you because this is kind of a Java 7 technique, and probably most software developers are still going to be using these things. Now, when we come to using executor service, you don't have to put in a sleep. The sleeps are put in for you automatically. Okay. Now, so the best way to show you is to explain sleep to show an example. So I'm going to create a thread. All right, new thread. And thread is going to have a lambda inside it. So this is going to implement the runnable interface. So I am going to have a for int I is equal to 0, I is less than 500 underscore 000. So that's 500,000. I go I plus plus. Now, so we're inside the for loop. All we're going to do inside the for loop is go counter plus plus. Now, so what's that counter going to be at the end of that loop? Starts off at 0, goes 500,000 times. So at the end of this loop, our counter is going to be 500,000. Yes? Huh?
One less.
Yeah. Okay. So it's going to be 499,999. Okay. Now, so I'm going to do it all in one line. Okay. Dot start. So that's going to take a set amount of time to do something. Okay. All right. Now, so thread is going to be doing along, doing its own thing. Now, I'm going to create another counter here. W counter is equal to 0. Now, this will show you the nature of threads. So this is a separate thread. Now, at the same time, there is a, what did they call it again? I need to get the right term for it. It's your system thread. Okay? So when you create a thread yourself, you have automatically 2 threads created. All right? Because there's a system thread. When you run your application, you have a system thread. So this is a separate thread. So you now have 2 threads running. Yes? Do you understand that? So threads without sleep, this statement is running on the system thread. I think that's the term for it. I can't remember what it's called. And this is your own thread. This is a user defined thread. So you have 2 threads running there. All right. Now, the threads themselves are asynchronous, so they're probably going to be running at the same time. Yes? Right. So I'm going to have a while loop down here. I'll explain all of this in a minute. So I'll go through it all first. I'll just type it all out first, and then I will explain what's happened. Now, so what happens when I do this? This is EX3. Now, right. So let's have a look at this. So this starts running 500,000 times. Okay. That's going to execute 500,000 times. Now, while that is running, this is also running. Okay, because while counter is less than 500,000. So we're in here, this starts running while this guy is still going through, while it's still doing its thing. So you have 2 threads running at the same time. Okay, so how many times does this run? The while loop runs 217 times while this guy is going 500,000 times. Do we see that? Now, it will give you a different answer each time here. 191 times, 210 times, 188 times, 186 times. So the while loop doesn't have to happen after this lad. They're happening at the same time. Okay? While this loop up here is going 500,000 times, this loop down here is going 163 times. Or run it the next time. Which one?
The while loop. It's not going.
Well, all that's happening. well, what's happening here, Kieran, is, right, so now this one will probably start first, but you're not going to be guaranteed that this thread, now, actually you are going to be guaranteed that's going to start first, all right, in this case. Now,
So, one question, so why do you belong to the system?
yes, yeah, so that belongs to system thread. Okay, that belongs to system thread. This belongs to our own thread. Okay, so this guy runs. Now this will probably start first. Okay, now this is on the system thread. All right, this is on the system thread, and it will probably start after this one, but it won't. It will start before this one finishes. Okay, so this will start before this finishes. So that means they're both running at the same time. Okay, they're also both accessing, but so this one increments counter, this one checks counter. Okay, and this will, so how many times does it check the counter? It checks us 206 times. So this runs 500,000 times. And as it's been incremented, so our second loop has to check it 206 times before it's above 500,000. Or I'll run it again. $108 times, 158 times, 267 times. Okay, so I put in here. Now, so I put in here, this while loop is part of the system thread. So this while loop is a task on the system thread. Okay, so it will start while the user defined thread is still running. So our for loop above and our while loop here are running at the same time. Okay, they're running at the same time. The while loop will keep executing until the for loop increments counter to be above 500,000. Okay, so this while loop also, you can't guarantee how many times while loop will execute. Okay, you can't guarantee how many times the while loop will execute. Run this numerous times and you will see that the amount of times the while loop runs will be different each time. That's what it is. This takes so many nanoseconds to do. All right, and the while loop is going to check it every 2 or 3 nanoseconds. All right, and you can't guarantee with absolute certainty how many nanoseconds it's going to take to complete 500,000 loops, because there's so many variables. Your machine could be connecting up to the internet, it could be doing some other thing in the background. So I run it once. Didn't take that long to do because there wasn't much processes running in the background. Didn't take much to do. 208. There might have been a little bit more of a process load, something else happening. All right. So here you have a for loop and a while loop running concurrently. All right. So what's happening inside the thread is synchronous. But threads themselves are asynchronous. Do we understand? All right. I'm going to do the same thing. Yeah.
You'd expect it to go a lot more times than 206, wouldn't you? Because it's double stuff that happen.
Well, but it just shows you how fast it is. It just executes. I mean, this is the system thread. Now we can define the time periods with checks. We can do that, right? And how you do that is something called sleep. Here we don't define it. I'm going to do the exact same thing in static void ex4. Watch. So it's the same code, but there's going to be one or two little modifications in it. So I'm going to copy this code. Now, the only difference I'm going to have is I'm going to go new thread. I'm going to put that guy there. Now, I'm going to put all of this inside here. Fudge. Hold on a second. Hold on a second now. Hold on a minute now. Where am I? Where am I going now? New thread. So, oh yeah. A minute now. So, I'll take all of this. So I need to go to that guy, to that guy, and I need to copy all of this stuff into it. Int w counter is equal to 0, and I put this guy in here. And I put this lad in here. Now, I know this code looks all over the shop, and you're thinking, what the hell is happening here? All right, so this is, so we have two system threads, or two of our own threads. All right, so this is thread 1, this is thread 2. So that means 3 threads running, yes? So there is, this is our first user-defined thread. And this is our second user-defined thread. We'll just see what this prints off. Take out this lad. Now, so I'm going, that should be okay. Go to main, examples are ex4. Now, here's the thing. As far as I know, if you use your own user-defined threads and nothing else, they're more efficient. All right. So here we can see that this is our first thread. This is our second thread. So everything we're doing is on our own threads. All right. So previous, we had a thread, and then we used the system thread. Here we've got our own two threads. So this is our first thread. This is our second thread. Now you can see that the while loop is executing. It never gets above 200. So it's a lot more efficient. Whereas with the previous one, if we look at the previous one, go back to main. I go to example.ex3. See it? 191, 175, 222. Having your own threads is more efficient. Okay. So, what's the difference between EX4 and EX2? Here, all tasks are on our own user-defined threads. Now, it could be, so you could have a thread that creates your GUI, right? And it could be calling all other methods. That's one thread that creates your GUI. You could have another thread that connects up to your database. You could have another thread that connects up to your file. You could have another thread that creates all your static variables. That's 4 separate threads. So rather than having them one thing happening after another, you can have the 4 things happening at the same time. Do you understand that? So this guy here is also roughly happening at the same time as that guy. All right. So rather than going from A to B, that goes from A to B, and that goes from A to B. But so this is thread 1. This is thread 2. Thread 2 could start in the middle of thread 1, or thread 2 could actually start before thread 1. That can happen as well. All right, but the order, what happens inside, still goes from A to B. So if you have big computations, lots going on, all right, and if you've got a hugely powerful machine, all right, still only doing things from A to B. If you have threads, it can be doing many things at the same time. Does everyone get me so far? Yes? So that is going to be faster than something that just goes 500,000 first, then does another 500,000 here. You want this thread to be running at the same time as this guy. It is running at the same time, all right? Because this only runs while the counter is less than 500,000. It only runs $169 times. Now it's starting to go up a bit. Is that EX3 or EX4? EX4. It's gone up a lot now. 158, 182, 191. It's going up again. Okay, so that's how you use threads. That's the basics of them. Okay, so you can imagine you're starting up your program. You want one thread to create your GUI, another thread to create your connections to your servers, your files, your whatever. All right, it's as simple as that. All right. In actual fact, when we get to Java FX, what you're going to be doing in your main, you're only going to have code like that in it. You'll have this code, you'll have a thread to create your GUI. You'll have a thread to connecting to all your various applications, your various Azure stuff whenever we fucking get that. And you have both of them happening at the same time. Any questions on that? No? Right. Now, so these are two user-defined threads, and our threads contain all of our tasks. So the both of these are running basically at the same time. Okay? So now,
System threads mentioned both of those threads.
yeah. Okay. Thing is, a system thread is actually managed. No, the system thread is a separate thread.
But he's not really, because that one's out.
Right, so that guy, right, so that guy is the system thread. That's our own thread. That's our own thread. So everything outside of those threads is on the system thread. Okay, so there's 3 threads around there. Now there's something called a thread scheduler. That's what's managing it. So it's a thread scheduler that's managing it. All right. Now I'm going to take this same code. It's the same code as EX3. So I'm going to static void EX5. Okay. So I'm going to go copy this code. Okay. Now, so down here, I am going to put in a line here. I am going to go thread dot sleep. All right. Now I need to go up here. I need to say throws INTERUPTED. Now I'll explain it in a minute. I'll type it up first and I'll show you. All right. So I'm going to call EX5. Now, this lad here is a checked exception, so I have to put in a try catch block. So I go try, I go examples.ex5, and we go catch exception. Now, so here's the thing. All right. It is recommended. Okay. So here, when you have something else accessing the same thread, all right, so this guy here is doing its business, okay? Now, this system thread is accessing our own user-defined thread, yes? Yeah? Okay, so I'll put in here. So this system thread is accessing our own user-defined thread. Now, well, because see, while counters inside here, right? Yeah, but you see, counter's been incremented inside here.
Yeah.
So so how does no counter's been incremented? It's so
Accessing counter values outside.
Yeah, but it's been incremented inside the thread, so it's accessing the thread. That's the way you say it. Okay, it is accessing the thread. All right. Now, so the system thread is accessing the user-defined thread. All right. I'll just take out that guy. Now, I think the way it goes is it's accessing this guy here. I think it's every 2 milliseconds, as far as I know. Okay, I think I'll check that for me. No, it's not 2 milliseconds. It'd be 1. No, it's not. Okay, so it's probably 0.01 milliseconds, which would be what? Oh, fuck. It's probably accessing it every 100 nanoseconds. All right. Now, what's actually happening is the following. All right. So there is a command called thread.sleep. Now, what that means is that this user-defined thread is going to check this thread every 1 millisecond. Okay. Now, there is a default setting for how many times it checks a thread. Now, it must be probably around 0.001 milliseconds, which would be around 100 nanoseconds, 100 billions of a second, approximately, I think. Okay. Now, what's that doing there is that this guy here is accessing this thread every 100 nanoseconds. Okay. Now, what .sleep does is it widens out that period. So how many times is it checking it here? It's checking it every one is going to be probably it's going to check it every 1 millisecond. Okay, so if it checks it every 1 millisecond.
So we're sending the system thread to sleep.
Yeah. No. Yes, you are. Yeah. Yes, you are. Sorry. Yes, you are. Okay. So it's telling this, check it every millisecond. How many times does it check it? 6 times. So how long does it take to execute? 6 milliseconds. Run it again. 4 milliseconds. 4 milliseconds. 3 milliseconds. 3 milliseconds. 3 milliseconds. Okay. Now that's a delay you put in yourself. All right. Now it's considered good practice to put in a delay. What that means is that's going to sleep the system thread for 1 millisecond. It's only going to check this every millisecond rather than every 0.001 milliseconds. That's what .sleep does. So if I change that to 100, only one time. Okay. So while this thread is going, this thread will only check it once every 100 milliseconds or once every millisecond. So you can see it's ran 3 times. So I'll put it in here. While this can only access other threads once every 1 millisecond. Okay. Thread dot sleep takes an int, which is the amount of times, amount of time this thread waits before accessing another thread. Now, it's considered bad coding practice not to put in some sort of delay. Okay? Reason being is, do you really need to check it? Take it out there. Do you need to check it 208 times? No, you don't. Probably just not to check it just. Let's say this is once every 100 milliseconds. Just checks it once. Okay, so it's considered bad coding practice not to put in some sort of delay. And this works the exact same way as for, so let's say I take EX4. And put it into static void EX6. Oops, shit, sorry. So I go static void EX6. And I put in, this is from EX4. So the second thread, I'm going to go in here. So it's, and we'll say 100 milliseconds. Now, the method itself, so you either have to put, so when you're doing a sleep throws an interrupted exception. It could throw an interrupted exception. So you need to go throws. This guy here, interrupted exception. So, oh, it's not fucking working. Hold on a second now, where do I put it? Give me a minute now. EX4, so where did I put it? EX5, just a second now. So EX. Actually, I'll take that out of there. And I put a try catch block around it, around the while loop. So I'll put all of this here. Try. All right, so that's the same thing. So while countless not reached yet, thread.sleep, this is going to, so instead of having a, so instead of having a throws exception here, you deal with it inside here. So we have a try catch exception. So this is static void EX6. Now I know the code looks kind of confusing. So this is our first thread. Thread 1. This is thread 2. Okay, now it'll put this thread to sleep after each iteration of the loop for 100 milliseconds. So it goes into this once. Okay, it goes into it once. It won't check any other threads for another 100 milliseconds. Okay, so I'm going to run this one. So EX6. All right, so loop is executed one time. So what does it do? This thread starts on its merry way. This one, int W counter is equal to 0. So while counter is less than 500,000, it's going to print off not reached edge. It's going to increment a counter by 1. It's not going to check another thread for another. So this thread is going to put itself to sleep for 100 minutes. So nothing else is for 100 milliseconds. Nothing else is going to happen inside this thread for another 100 milliseconds. So up here, same thing. Okay. After the first iteration of this loop, this thread will go to sleep for 100 milliseconds. So will not access any other thread for 100 milliseconds.
And that's when your own second thread, own thread, access the first one, right? Because it's picking up on the
Yeah.
on counter. Suppose the first thread is something referring to the second thread, you go into recurse.
Yeah,
Loop, then would just,
you can have problems with it because it's always accessing a thread. It's either the code is always on some thread. If it's not in your own thread, it's on the system thread. So it's, so guess what? You've been working with threads all along. If you type code normally into Eclipse, you're typing it on the system thread. You're putting tasks on the system thread. So here in this one, what you're doing is, this is a thread. This is the system thread. So you're always accessing a thread. So this thread.sleep, it's putting the system thread to sleep. Okay, but all other threads are still running fine. All right, so it's considered bad coding practice not to put in some sort of delay. Does it need to check every 50 milliseconds or what, or 50 nanoseconds? No, it doesn't. Okay, it's 100 or 1,000 nanoseconds is what it checks. So all this does is it puts the system thread. So this puts the system, this thread, which is the system thread, will go to sleep for 100 milliseconds, will not access any other thread for 100 milliseconds. And this one here, this is our own thread. This is thread 2. So everything is contained within, or sorry, this is the system thread. This is thread 1, which is user-defined thread. So our own thread. And this is thread 2, our own thread. So not reached yet. So when you go counter plus plus, what you're actually doing, you're accessing that thread there. You're always accessing some thread. Okay, it doesn't matter. Once you have code there, it's either on the system thread or your own threads. All right, so you're always using threads. When you're not explicitly using them, you're using a system thread. Here, I think it's snowing. So here, a little dappling. Woohoo! Making snowmen. You're not allowed to throw snowballs at your tutor, okay? That's a new rule. So we have a system thread, we have our own thread, and this is our own thread too. So what happens here, thread sleep 2, this puts it to sleep for 100 milliseconds after the first iteration of the loop. Okay? It puts it to sleep after the first iteration of the loop. And now sleep, so this could throw an interrupted exception. Exception. So it has to be put in a try catch block or have throws in the method signature. Okay, so
What is that interrupted exception? It says put to sleep.
yeah.
How could it then be affected? Interrupted sleep. Do you know what I mean?
Well, if something happens here, if something causes that not to finish, okay, you're going to get an interrupted exception.
While that was asleep,
Yeah.
something affected that.
Yeah, exactly. Okay, because that's what it is. It's an interrupted exception. What's it called again? Interrupted exception. So it's anything that interrupts either of your threads is going to give you an interrupted exception. Let's say you could have an array index out of bounds exception up here. That's going to cause an interrupted exception down here. Or you could have an array out of bounds index exception here. Okay, so anything that interrupts your sleeping or your threads is going to give you an interrupted exception, as far as I know, Jason. For instance, I'll create an index out of bounds exception just to see what happens. I don't know what's going to happen. Now, give me a minute. Now, what does that give us? Now, yeah, that'll probably cause the exception here. Let me just see. Oh God, look at that. It keeps on going forever. So that will, do you know what? We won't do exceptions of them yet. I think we do a section on it, so we'll just take them out, all right? Now, so everything you do in Java is on a thread, all right? So even when you don't think you're using threads, you're using threads, all right? Now, so main problem with thread is all about their management, okay? So Java 8 brought along, so you're recommended to sleep them. Now there's also something called closing them. Ideally, you're supposed to close, well, not ideally. You can try and close threads. However, it's very difficult to close them in Java 7. All right. What they recommend is that they finish themselves naturally. For instance, this thread will finish naturally once it gets to 500,000. This thread here will finish as soon as this thread finishes. Okay? Now, so you have to start them. You can try and finish them. You have to make sure that it's accessing the right version of a variable, so on and so forth. Okay? So, because remember, this thread will most likely be running the same time as this thread. All right? That's another reason to put in a sleep. So it'll only try to access this thread once. All right? Now, so There's lots of things that can go wrong with threads. Yeah.
In the second thread here.
Yeah.
How would the counter end up being?
Here's the thing. Right.
The counter would end up being half a million.
Yeah. You'd think, wouldn't you? Wait till you see. Okay, this is EX6. Yeah, it's a counter is. Right. Yeah, I have the W sleep in the wrong place, have I? No, I don't actually. So I want counter because counter should go 500,000 times, yeah?
Yeah.
Okay. Now, see, here's the problem, right? Do you know what the problem is there? Why is that only giving me 14,247 and not 500,000? Why? It's going to probably give a different answer each time as well. $9,859. That's an awful lot short of 500,000. Why isn't it giving me 500,000?
You're running multiple, yeah.
Here's the thing. All right. You have 3 threads running, right? You have 3 threads running.
You have more than 3 threads running. Yeah, the other
Yeah. Yeah, actually, yeah. That is true as well. Okay. At the start of it, I'll put counters equal to 0. That should change something as well. Hold on. So I'll put counters equal to 0 here. Right. Now, what's actually happening is following. Okay. So this thread is running. This thread is running. And our system thread is running. All right. They're all roughly running at the same time. All right. So the first thing that happens inside the system thread, inside, check this out again. So just a minute now. So this, you have T1, you have T2, and you have the system thread. This is the system thread. All right. They're roughly running at the same time. So T1 is all the time incrementing its counter. T2 is just checking counter. This one here is printing counter. So what is it doing? It's printing out in the middle of, or it's just printing out at the very start of T1, which is 15,838. It doesn't wait till it gets to the end of T1. Do you get that? So it's probably never going to be at 500,000. What happened there? 10254. Now, a way for it to make sure it gets to 500,000 is the following. All right, how would you try to ensure that that's going to be 500,000? You do this, lad. So that's going to be the system thread. Go and fork the fucking thing there, sure. Try. Catch. Now it gets to 500,000. All right, because now I'll try and get all of this code. I'm going to minimize it so you can see it on your own screen. All right. So this is our first thread, T1. This is our second thread, T3. I'm going to take out the sleep part. I don't want that there now for now. All right. I know it's 27 minutes past. I just want to finish explaining this and you can go to lunch. You can take a long lunch because you've been such good boys and girls. Right, so this is T1. So T1, T2, and we'll call this one T3. Now they're roughly going to start all at the same time. Okay, so this guy is running, this guy is running, and this guy is running. Now this guy is running, it's going to be incrementing counter the whole time. All right, it's going to be incrementing counter the whole time, and this runs. This is running. Now there's a sleep here, so it runs once, and then it's going to put this thread to sleep for 100 milliseconds. Okay, this guy just runs. Now it runs when the counter in T1 is at 8,191. Okay, it runs when that counter is at 8,191. So what's it doing? It's accessing that thread. The thread hasn't gone to completion yet. Okay, it hasn't gone to completion yet. So if you put a sleep in here, that means that that one runs. That one runs. Okay, now this guy here is going to go to sleep for 100 milliseconds. The system thread is going to go to sleep for 100 milliseconds after this thread starts. So this thread starts, then this guy goes to sleep for 100 milliseconds. Okay, so this one here, this goes to sleep for 100 milliseconds. Then this goes to sleep for 100 milliseconds. Then this runs. Then you'll get to 500,000. All right. Whereas if you don't have a sleep in there, it's going to print off 8191. Okay. Can you see what's happening there? It's accessing that counter before it's got to 500,000. This thread up here is still running while this accesses the counter. Okay, we'll do a few more of these examples when we come back from lunch. Okay.
Don't be comfortable that happening as well.
No, double counter will only be at 1 because I have a sleep inside here. Because it goes in here and not reached yet, double counter. Then this thread goes to sleep for 100 milliseconds. And by the time it wakes up, this guy is at 500,000 and this counter less than 500,000. So counter will only be 1. Okay, we'll do more of these examples when we come back. Okay, so I'm starving. All right. Video.